Hi, welcome to a new chapter, Limits and Continuity. Let us look at the overview of the chapter. Basically, we have the three subtopics. First is about evaluation of limits, rational expression, and also polynomial expression. And the most important part is how to find the existence of limit, which is involve one-sided and two-sided limits. Second, asymptote, vertical or horizontal, and the last one is about the continuity. So are you ready? Definition. If fx becomes closer to a single number L when x approaches a from left or right side, where the a is any real number. Looking at the diagrams, approaches a from left we denote as a minus, approaches from right we denote as a plus. By looking at the curve, the two-sided values will stop by y equal to L. So we say that the limit approaches a is L. Example 1, a linear function x plus 1 is given. By looking at the diagram, the movement of the blue point from left or right will stop at the y equal to 3. So this is show that the left side limit is 3, right side limit is 3. Therefore, we can conclude that the limit approaches to is 3. So this is the example of linear function. So how about when there is a piecewise function is given, how we determine? By looking at this example, so from the example, the boundary number is 2. So the x approaches to from the left is a linear function x plus 1. From the right is a quadratic function. Both sides stop by y equal to 3 as well. So this is show that two-sided limits are equal. Therefore, we can conclude that the limit is 3. So in the proper method in figure out the existence of limit, we can start from graphical method. From the example 3, we need to figure out the left side limit from the diagram. So from the diagram, we found that is a horizontal line y equal to -2 when the x approaches 1 from the left. At the same time, when the limit approaches 1 from the right, that is a linear function. And also the values of y equal to 2 is not the limit. Because when approaches 1 from right, the graph is pointing to the empty circle which is y equal to -2 as well. Therefore, we can conclude that the limit is -2. Example 4, when x approaches 1 from left and right, respectively with the horizontal line at y equal to -3 and y equal to 3. So we write in the notation as following. Limit approaches 1 from left for the function gx is equal to -3, and limit approaches 1 from right for the function gx is equal to 3. So what we can conclude here is, since the two-sided limit is not equal, therefore the limit does not exist. Example 5. Determine the limit exists or not for the function hx when x approaches to 0. So now let us focus on x equal to 0 and we divide it become left side and right side. From diagram, the left side limit, we will focus on the curve from the -5 until x equal to 0. So we found that approaches 0 from left, the y value is stopped by y equal to 4. So the limit is equal to 4. When approaches the 0 from right, we focus on the right side of x equal to 0. The curve is moving from the x equal to 5 to the 0. It is also stopped by y equal to 4. So the limit exists. Remember, when there is a dense circle or empty circle, both limits consider y equal to 4. After we using the graphical method in determine the existence of limit, let us proceed to the second method, which is algebraic method. There is no diagram provided, but the piecewise function is given. So firstly, we need to identify the boundary number from the question. Based on this question, the boundary number is x equal to -1 and 1. What we need to do now is, let us draw a timeline. Label the boundary number in ascending order. The next part is we fill in the blank the corresponding function based on their interval respectively. So from the question, we are asking to evaluate the limit when x approaches to 1. So we just need to focus on x equal to 1, approaches 1 from the left, approaches 1 from the right. Their corresponding function is x squared and 4 minus x squared. We start to evaluate by direct substitution. Do not forget to write the proper notation for the left side limit and right side limit. From here, after direct substitution, the left side limit equal to 1, but we get that the right side limit is equal to 3. Obviously, the conclusion it will be, since the left side limit is not equivalent to the right side limit, therefore the limit does not exist. From all the example that's given here, I hope that you can understand how to find the existence of limit. Hope that you like it. Thanks for watching. See you. Bye.